Many thanks, my dear viewer, for joining us today again on this special occasion and a show, The Knowledge Quest. My name is Mr. Mautia Eliud, taking you through mathematics. Our topic today is longitudes and latitudes. It's a topic in maths, and I want us to know how do we calculate distance under longitude and latitudes. So I'll just be able to give you a glimpse of what the topic entails and different areas that you need to understand as a student how to go about this topic, longitudes and latitudes. So if I borrow information from geography, how do I define a latitude? If you understand what's a latitude and what's a longitude, then the topic will be easy to go through very fast. So a latitude is an imaginary line that is drawn on the globe to show how far a place is north or south of the equator. Meaning that if I have a globe and I have an equator there, which at 0 degrees north or south, any line running from east to west or west to east, giving distance from the equator. This is the equator. All these lines, B, C, all of them are latitudes. Get to understand that. Those are latitudes. What's a longitude? The same definition, but now they show how far a place is east or west from the Greenwich meridian. So this is my Greenwich meridian. So any point from the Greenwich meridian moving towards the east or west, all these D, E, F, all these are longitudes. So latitudes, they are moving horizontally and longitudes are moving vertically. So once you understand that, then we can be able to move very easily. Now, under this topic, we shall be able to calculate distances of different points. We are going to calculate distance from different points on the globe. And before that, I'm going to start with the location of points. That's the first subtopic under that topic, longitudes and latitudes. How do you locate a point on the globe? So points are located on the globe following that rule that you start with the latitude, then the longitude. Okay? You always start with the latitude, then go to the longitude. Meaning that if I have 20 degrees east, 40 degrees north, or I have 20 degrees north and 40 degrees east. If I ask you a question, which one is right between the two? So the second is right. We don't use the first one because the rule is the latitude, then the longitude. And I said the latitude, they move from east to west, up from the equator and down from the equator, meaning that going towards the north or towards the south is the latitude. Longitudes is either east or west. So this one, the first one, is wrong. So mark that. If you interchange, then you are wrong, and you'll get no mark for that. So always remember, when you're locating points, you locate points from the latitude to the longitude. And how do you do that on the globe? I've just said we have 20 degrees north and 40 degrees east. Locate that, draw a globe. Ensure you mark the point which is 0 degrees north or south, which is the equator. Is 20 degrees north above the equator or below the equator? Above the equator, correct. Because from the equator towards going up, we are going towards the north. Equator coming down, we go towards the south. So my 20 degrees can be anywhere above this, but you need to be mathematically correct. You can't draw 20 degrees here, because if you're moving from 0, you're increasing numbers towards 180 degrees. So 20 degrees approximately should come somewhere there, and say this is my 20 degrees north. 40 degrees east from the Greenwich meridian. Is east on the right side of this line or on the left side of this line? Correct, it is on the right side of the Greenwich meridian. So you can approximate the point 40 degrees east there. Therefore, the location of this point is the point of intersection between the two lines. That is my A, if that was A. So intersection of the latitude and the longitude, where they meet, marks your location of that point. 20 degrees north, 40 degrees east. Suppose I have 40 degrees south and 20 degrees west. How do I locate that? Because every single subtopic under this topic, you must be able to know how to locate for you to understand which direction you're supposed to calculate distance towards. So this, I'm going to have a globe. First of all, you locate. This is the Greenwich meridian is this one, and this is the equator. So 40 degrees south is below the equator. So let's say come there. This is 40 degrees south. And 20 west, the left side of the Greenwich meridian. So mark it at that point. That is 20 degrees west. So point of intersection between the 2 points marks your point. For example, this was point W. That is the location of point W on the globe. First, locate the latitude. Second, locate the longitude, right? The point of intersection between the 2 points marks your point W. Correct. Let us now start calculating distance. We are done with the location of point. I've said, first of all, you start with the latitude, then proceed to the longitude. So the first I have is a great circle. Then we shall go to distance of the small circle. Why do we say it's a great circle? So for any points to be considered as great circle, specify this point that all the points between each other must be along the longitude. Mark that. So for a point circle, the points between the distance between the 2 points, all of them must lie on the same longitude. If you find that, then you're dealing with a great circle. For example, if I have 20 degrees north, 40 degrees east, and I have 40 degrees south and 40 degrees east, this point A and this point B. Locate this point on the globe for me to know if AB, all of them lie along the same longitude, to be considered as what? Great circle. So before you do any calculations, ensure that you have located these points to know where they fall. Now, let me just locate this. On the globe, 20 degrees north, 40 east. So point of intersection is my A. Then 40 south. This is 40 degrees south. And 40 east, so the same longitude. So that is the point B. So you realize that A and B, all of them are along the great circle, along the longitude, and therefore they are great circle. So all the points, if they fall along the longitude, they are considered as great circle. And what is the formula of finding distance between 2 points on a great circle? The formula is theta over 360, 2 pi r. That is the formula. Now in this case, NB, we shall use the radius of the Earth as 6370 kilometers. Mark that at the back of your mind. Unless the examiner tells you to use a different distance in terms of the radius of the Earth, then you must be able to know that the radius of the Earth is 6370 kilometers. Now, what is the distance of A and B? Distance on the great circle, having the formula. How do you get theta? Most important and critical point to understand. How do you get theta? Let me just write that formula up there. The formula is theta over 360, 2 pi r. And I've said radius of the Earth, 6370 kilometers. Mark that as well. So how do you get radius? Not radius, but theta. The angle between A and B is theta. Now, two things important. If the 2 points, the difference between the latitudes are on the same side. By same side, I mean north, north, south, south. If both of them are north, north, and south, south, you subtract latitudes. That's point number one. If the latitudes are different sides, for example, north, south, or south, north, whichever, then you add the latitudes. Note that when you're dealing with great circle, you plot it, you get the difference on the latitudes. Later on, when you go now to small circle, we shall be able to see if you're getting difference from the latitudes. But now you're dealing with the longitude. So get the difference from the latitudes when you're dealing with the great circle. Now this is north, this is south. Are they on the same side or different sides? They are on different sides. This one is north and this one is south. And therefore, if they are different sides, then we add the two to obtain the angle theta. Meaning that I'm going to have what? 20 plus 40 give me 60 degrees. So my formula is theta over 360, 2 pi r, which is now 60 over 360, multiplied by 2. 22 over 7 is the pi, then multiplied by the radius, which is 6370. I've just said, in case an examiner gives you a different radius, then you use that different radius. If not, then at the back of your mind, you know that the radius of the Earth is 6370. Now let me calculate this one. By 61, by 60 is 6. By 21, by 2 is 3. By 71, by 7, 910. 22 multiplied by 910 divided by 3. What is 22 multiplied by 910? 22 multiplied by 910, we get is 20,020. then divided by 3, I'll get 6,673.33 kilometers. Remember, when you're having a decimal place, always leave your answer at least to 2 decimal places for you to get the correct answer. Now, this is the distance between A and B. So it's along what? The great circle. And for any points to be on the great circle, all of them must lie on the same longitude for them to qualify to be the great circle. Let's now do something else again on the same subtopic of the great circle, so that you can be able to understand exactly where we are going and where we are coming from. I want to give another example. For example, I have now 40 degrees north, 30 degrees east, and I have 20 degrees north and 30 degrees east. This point M, N. Calculate the distance between point M and N, given these points 40 degrees north, 30 degrees east, 20 degrees north, and 30 degrees east. So first of all, before I do it, I want you to try. It is good as a student and see how far you've gathered that content. Then after that, I'll be able to go through it and see or not. First of all, locate the point, identify if they are lying on the same longitude, and be able to perform the procedures of getting the formula and then substitute the necessary numbers on this formula and get the answer. I'll be able to get back to you after this short break. Welcome back. I hope you've done this assignment, and let me try and do it once more from here to see how far you've gone with it. Now, the first thing I said, you plot or you locate these points on a globe. So let me locate that point. Remember, this is 0 degrees north or south, which is the equator. And this is the 0 degrees east or west, which is the Greenwich meridian. Now my 40 degrees north approximately should be there, and 30 degrees east. This is 30 degrees east. So point of intersection, marks my point M. Then 20 degrees north is below 40, therefore probably there, 20 degrees north. And the same longitude, which is 30 degrees east. So point of intersection, that point N. Now you realize that my location of 40 degrees north is here, and 30 degrees east, it's here, with 20 degrees below 40. Remember, it's from 0 going up to 180, so 20 comes below 40. Now, once you locate this point here, you realize that M and N, both of them lie along the same longitude, and therefore they qualify to be great circle, right? So distance, I said, between M and N are great circle, and the formula is theta over 360 2 pi r, with the radius of the earth being 6370 kilometers. So if you're joining us now, I said the radius of the earth is 6370, unless the examiner has told you to use a different radius, then always use 6370. Now, how do you find theta? If we are dealing with the longitudes, we find the difference of the latitudes to get the angle theta. If both of the points are lying on the same side, we subtract. If they are lying on different sides, north and south, we add. Now you realize that this is north and north, so both of them are on the same side. We subtract the two, so that is 40 degrees minus 20 degrees, it gives us 20 degrees. So that is my angle theta. Put it there. So 20 over 360 multiply by 2 multiply by 22 over 7, which is the pi, multiply by 70 kilometers, which is the radius of the Earth. Perform your mathematical procedures from here. 7,17910 0 21 218 2 ones 29. So I'm going to have 22 multiplied by 910 divided by 9. 22 multiplied by 910 divided by 9. 2,224.44 kilometers. That is the distance of point M and N, which is given like that. So the procedure is just simple. Ensure first you locate the point, and if they lie on the same longitude, they are great circle, and the formula for great circle is this one I've just given you, with the radius of the Earth being 6370 kilometers. For those who are joining us now, I just want to do one more example. Then we cement that information before we go to the other circle, which is the small circle, which is actually the opposite of this, and just with an additional formula of the same. Another example I can give is, for example, I have 60 degrees north with 20 degrees east. I have 40 degrees south and 20 degrees east. Point A and B. Calculate the distance between point A and B in kilometers, given the point of A is 60 north, 20 east, 40 south, and 20 east. First of all, locate this point on a globe. Locate the point on a globe. Where is 60 north, 60 degrees north, and 20 degrees east. So the point of intersection is our point A. Then point B is 40 south, below the equator, and 20 degrees east. So point of intersection is my point B. Again, you realize that A and B, all of them are on the same longitude, 20 degrees east. And therefore, now you get the difference of the latitudes to obtain the angle theta. So my theta will be what? Now this is north and this is south. Different sides. We add. So I'm going to have 60 plus 40, giving me 110. 100 actually, not 110, but 100 degrees. So that will be my theta. My formula is theta over 360 to pi r, which is now 100 over 360 multiplied by 2 multiplied by 22 over 7 multiplied by 910. I've not divided that, so the radius of the Earth is 6370. So we proceed. The first 0 goes, by 2 is 5, by 2 is 18, by 2 is 1, by 2 is 9, by 7 1, by 7 9 for 63, 7 is 1, then 0. So I'm going to have 5 multiplied by 22 multiplied by 910 divided by 9. If you perform that, you're going to have 22 multiplied by 5 multiplied by 910. You obtain is 10,000, 100,000, 100 divided by 9 will give us 11,122.22 kilometers. So that's the distance between point A and B on the globe. After now you've located that, you realize that this is a great circle, and the formula I've just given you is this for calculating distance of the great circle. For you to get theta, you must know if you're dealing with the longitudes or latitudes. Then get the difference of these parts. If it is north and south, you add. If it is north and north, you subtract. South and south, you subtract, and by so doing you'll be able to perform this other arithmetic easily to obtain your answer. Now, that is the great circle. I just want to tell you what we're going to discuss next. As you prepare yourself, we are now going to discuss about small circle. And I just want to give you a glimpse of what a small circle entails. And therefore then, after which we are going now to convert kilometers to nautical miles in our next segment. Nautical miles can be written as NM, and kilometers is KM. We shall know how do you convert kilometers to nautical miles and how to convert nautical miles to kilometers in our next segment. But now let me just give you a glimpse of what a small circle entails. For a small circle is the opposite of the great circle. It means the points lies on the same latitude. The points lie on the same latitudes. For example, if I have 20 degrees north, 40 degrees east as my point A, and point B, 20 degrees north and 20 degrees east west, for example. So if you locate this point, you realize that what? This is my 0 degrees north and this is my 0 degrees Greenwich meridian. My 20 north is there and my 40 east is there. Then again 20 north, so my point A is there. My point B is 20 north and 20 west, so my west on this other side, 20 degrees west. My other point is here. So you realize that point A and B, both of them lie along the same latitude, and therefore they are a small circle. Formula for this is theta over 360, 2 pi r cos alpha. So the additional thing under small circle is cos alpha. Theta, I said you get the difference between these points. Now, since we're dealing with now small circle, we get the difference of the longitude. This is east, this is west, so we add. But for now, to get alpha, you get the point shared between now this A and B. Which point do they share? They share 20 degrees. So your alpha will be 20. So we are going to have the degree here is 40 east and 20 west. We add, which will be now 60 over 360 times 2 times 22 over 7 times radius is 370. Cos alpha angle shared, not angle, angle shared is 20 degrees. Now you can perform that mathematical part of it and see how far you can go with that. So that's just a small glimpse of what we are going to handle in our next subtopic under small circle, and later on how to convert kilometers to nautical miles and the reverse of it. After which now we shall proceed to longitude and time. Then you'll be able to know where you are, like in Kenya, how many hours are we ahead or before Ethiopia, and such like stuff. We shall be able to handle it when we now come to longitude and time. But I want to leave you with an assignment. You do this for me, at least 2 or 3 questions. 20 degrees north, 40 degrees east, point A and B, 25 degrees south, 40 degrees east. Point B, let's have 40 degrees north, 60 degrees east, then 80 degrees north, 40 degrees west. This is MN. And the last one I want to leave you is with point XY, 20 degrees north, 40 degrees west, and let's have 40 degrees south, 40 degrees west. this point x, y. Okay, so try this, 3 of them. Locate, first of all, draw a globe, locate this point, identify where they fall. Are they falling on the same longitude or the same latitude? If they fall along the same longitude, then they are great circles. And if they are great circles, use this formula for great circle. If they are small circle, for small circle, and use radius of the earth as 6370 and pi as 22/7. Just give you a hint on how to go about it. So locate, do that, send us your feedback. We shall be able to get back to you and tell you where you're going wrong or right. Where you're going wrong, we shall be able to boost you and ensure that you grow your mathematical skills day in, day out with our help. So stay tuned, and until next time, be blessed.